Okay, let's begin today. So we're going to start where we left off last time, which was talking about in-order superscalars. So as you may recall, just a brief review, we were talking about these sort of a little bit more complex pipelines. We were able to execute multiple instructions at the same time. Sometimes instructions had to sort of be steered, if you will, between the A and the B pipe coming from the two different instruction registers. We have to double our decode. We need to check to make sure that there's no dependencies between the instructions we're trying to issue at the same time, and our decode logic will do that, so there's going to be some sort of cross-communication inside of there. And in our previous example, we were looking at an asymmetric pipeline. So what I mean by that is, loads and stores went down this pipe, and branches and ALU ops went down that pipe, and also ALU ops went down this pipe. So where we left off last time was talking about alignment and how do we deal with fetching multiple instructions from an instruction memory or instruction cache, but at the same time, how do we not have to make this structure have many, many ports, for instance? Or does it have to have many, many ports? So we looked at a basic piece of code here, which has a whole lot of interesting alignment issues. So at the beginning here, we were basically fetching instructions which were nicely aligned into the cache's blocks. And then this one was OK. We jumped to the beginning of a block. That was fine. Here we jumped to the middle of a block. And depending on how our cache was implemented, we might need to do sort of two fetches. Let's say you can only read out of your cache half a block at a time. Then you might have to do a fetch to get this and fetch to get that. And then here we even have things which sort of cross cache lines or cross complete cache blocks, which is quite a bit harder. So let's take a look at this. So if we have some alignment constraints, so let's say the alignment constraint we have here is that you can only fetch either from the first half or the second half of a block at a time. And if you're trying to execute something which straddles a cache line, you're going to have to fetch even more data. So as you can see, if you recall from this figure, this, and that instruction or piece of data in the RAM, when we go forward, we're basically going to be fetching extra data with that alignment constraint than we would have been fetching otherwise. This gets even harder. It's OK to sort of overfetch. It's another thing if you actually have to sort of straddle a cache line here. And because the question comes up, can you fetch those two at the same time from the cache or not? And we'll look through an example here where we're going to look with these alignment constraints and see that, no, if you can't actually fetch that, you're going to be introducing what is effectively dead cycles going down the pipe, which hurts your clocks per instruction. So here is the same instruction sequence that we had here. And these dead instructions that go down the pipe here, or killed instructions that go down the pipe, are actually just these three X's. So we've effectively overfetched. And then, when we go to overfetch, let's say here we fetched 208, but we had to fetch 20C, and that instruction is going to go down the pipe and not actually do anything. So you can see that you can actually, when you have alignment constraints, you basically can just introduce extra extra dead instructions going down the pipe, and you're not actually going to be using that. And that's not necessarily great.